Good morning. Lecture 5 under Unit 1 Principles of Work Zones Traffic Management Plans. So, in this lecture, we are going to see some of the commonly used terms in this WTMP. The first one is the shadow vehicles. Shadow vehicles, which are security vehicles or service vehicles, or the moving trucks, which can be moved from one place to the another place, fitted with attenuators spaced at a short distances, giving physical protection to workers and equipment and machinery from traffic approaching from the rear. Similarly, trailer mounted attenuators may also be used as shadow vehicle to protect workers and machinery in work zones. So this kind of vehicles usually we can see in the work sites. In the back side of that vehicle, some flashing amperes are fixed, which gives a better attraction or a bit better awareness for the road users that some work is going on. Truck mounted attenuators or vehicles equipped with energy absorbing barriers designed to enhance highway safety by protecting workers and minimizing the severity of crashes. The shadow vehicle you can see in this. So there is a attenuator, and rear side you can see the alternative yellow and black color strips. So this gives a better visibility. And you can see in the back side there is a shock absorber also fixed. Even some vehicle comes and hits, it will absorb the shock. It won't cause any damage to the vehicle as well as to the worker. So it safeguards the work zone. So they usually parked in front of the work zone or starting of the work zone, which give a indication that some work is going on for the worker, the road users. So another kind of shadow vehicle. The shadow vehicles are used in moving operations to protect work vehicles and workers from traffic approaching from the rear side. So the rear side is facing towards the moving traffic. They are moving trucks with attenuators spaced a short distance from the operations. Autonomous shadow vehicle or driverless and follow a lead maintenance vehicle, increasing productivity and reducing personal risk. So this kind of shadow vehicles also nowadays available. There is autonomous shadow vehicles which moves without any kind of driver. Next, the speed breakers. So this is also another important term which is frequently used in WTMP. So speed breakers are the humps created for slowing down the traffic. They shall be constructed with a premixed bituminous concrete or shall be as per the design standard specified in the IRC code. The rumble strips are also another kind of speed breakers. So these speed breakers are commonly used to reduce the speed. The main aim is to reduce the speed. However, the design and type of the speed breaker is critical. So what kind of speed breaker at which location, whether it is urban or rural, expressway, so what is the speed of the vehicle? Considering all these things only, we need to decide what kind of speed breaker we are going to use. So speed breaker reduce the speed and result in an efficient traffic flow. The advantage of speed breakers is that they can be easily placed at an identified location. So easily you can construct and you can place it at any place. The degree of the effect depends upon the profile, the height of the speed breaker, what gradient we are given, length and the cord length and the material used for the design. The humps as a speed breaker reducing device work on the basis of the slight inconvenience in the form of a jerk or vertical oscillation caused to the driver. The driver understands that the greater speeds, higher the inconvenience, thus the general tendency to slow down. So if your vehicle goes at very high speed, it gives very huge inconvenience for the driver. So naturally he reduces the speed. Although it is defined that humps contribute in speed reduction, the degree of its effect is known to vary with the profile, height, gradient, slope, length and material used. Usually there are three types of speed breakers usually used: circular hump, trapezoidal and sinusoidal hump. So it depends upon the chord length. It varies from some 12 meters to 113 meters. So IRC code book is available for this. IRC 99 can be referred. Traffic calming devices and reverse speed breakers also discussed. It can be referred. Stop and go boards. So this type of arrangement is made where if you want to operate two-way traffic in a single lane. So part of traffic, the one-way traffic is we need to stop, the another way opposite direction is opened, and they close. After some time they close the opposite side and open the existing side. So likewise, if using humans, employing humans, the stop and go signboards, we can do this kind of operation at construction site. So it's very common in construction sites. The stop and go boards are the handheld signs of circular shape to control traffic manually on alternate one-way operation. Sometimes they use flags also for this operation. So you can see in the yellow color in the drawing, that is the work site. On either side, person stands and operate the traffic. Lateral buffer space. So it is one of the important term is the minimum buffer distance to be maintained in the lateral direction from the moving traffic. That is distance measured from outrage line marking of the carriageway used by the traffic in the work zone and the edge of the work area constituting the actual workspace. So a portion of the closed right lane that is to the left on the signboard. So it is the lateral buffer zones are very critical. So if so we cannot give so much huge buffer gap, but if it is there, it is good, more safe. But due to the construction site, they occupy certain space on road. You can see in this picture. So there is some barricades also placed around, or traffic cones are placed around the work zone. So there is on either side that tappers are there. So you can see the traffic is moving. So the gap between the actual work zone, the hatched area to the edge of the road where the traffic, here the rightmost lane, okay, where the traffic is moving. So the distance is called the buffer zone, right? Lateral buffer zone. Marshalling torch. So it is used in during night time especially. So marshalling torch is the torch and a durable hand flasker used by marshals, that is traffic operators, flagman, working on normal or rectangular batteries, rechargeable batteries with normal LED bulbs, and would provide warning signal for impending hazard or danger of construction zone, repair sites or trenches or digging of road tunnels, etc. So on either side of the work zone, the marshal stands and by hand he will show there is some warning sign. So you can see in this picture the typical marshalling torch. Rechargeable batteries are used for this torch. So using this by handheld torches, you can operate the traffic, especially during night times. Next, the New Jersey barrier. A New Jersey barrier is a reinforced concrete barrier of a specific shape used to separate moving traffic on workspace, generally used in work sites of longer construction period. So it is made up of reinforcement cement concrete. So once placed, it is, since due to heavy load, it gives better protection for work site. They are designed to minimize vehicle damage in case of incidental contact while still preventing the crossover case of a head-on collision. So this is that design is accordingly made. Jersey barriers are also used to reroute traffic and protect pedestrians during highway construction. You can see the New Jersey barrier, typical New Jersey barrier. It is also known as New Jersey wall. Is a compact concrete structure used to separate traffic on roadways. It was developed in the year 1950 in New Jersey, United States, to divide multiple lanes on a highway. Jersey barriers are designed to redirect a crash and absorb impact. They are commonly seen along highways, at construction sites, and in parking lots. A Jersey barrier or Jersey wall, or even say Jersey bump, is a modular concrete or plastic barrier employed to separate lanes of traffic. It is designed to minimize vehicle damage in case of incidental contact while still preventing vehicle crossover, resulting in a likely head-on collisions. Jersey barriers are also used to reroute traffic protection. They are named after the US state of New Jersey, which first started using the barrier as separators between lanes of a highway in the 1950s. The barrier are also known as a K-rail, a term stipulated in California Department of Transportation specification for temporary concrete traffic barrier, which was started using concrete median barrier in the mid-1940s. Over time, different variants were created. Taller variant such as the Ontario Tall Wall proved more effective at stopping vehicles and had the added advantage of blocking most oncoming highlight. More modular variants, including plastic water-filled barriers, have been created. Next, the work zone end. The work zone end is announced by a signboard, is the point where the last temporary traffic sign is posted to indicate the end of work zone. A normal operation of traffic resume from this post. That is point. So it indicates the work zone where from you can go at normal speed. So generally in work zone there is a speed reduction due to the lane reduction and all. So after this work zone end, the traffic can move at normal speed. So this is one of the important signboard which must be kept at the end of the work zone. So another video we are going to see about temporary traffic control zone after this lecture continuously. References. Thank you.
Welcome to Maintenance of Traffic Training Part 3, Temporary Traffic Control Zones. When traffic is affected by construction, maintenance, or utility operations, traffic control is needed to safely guide and protect motorists, pedestrians, bicyclists, and workers in and through work zones. The traffic control zone is the area between the advance warning sign and the point beyond the work where traffic is no longer affected. Most traffic control zones can be divided into 4 areas. In this part of the training, we'll look at each of the areas and examine them for one direction of travel. If your work will affect more than one direction of travel, the same principles covered here will apply to traffic in all directions. The MUTCD describes 4 components of temporary traffic control zones: the advance warning area, the transition area, the activity area, and the termination area. Crashes can occur in all of these areas if they are not properly controlled. The advance warning area prepares drivers and alerts them as to what's coming. An advance warning area is necessary for all traffic control zones because drivers need to know what to expect. Before reaching the workspace, drivers should have enough time to adjust their driving patterns. In the advance warning area, traffic control devices may vary from a series of signs starting a mile or more in advance of the workspace to a single sign or flashing lights on a vehicle. The advance warning area from the first sign to the start of the transition area should be long enough to give the motorist enough time to respond to the traffic control devices. Next is the transition area. When work is performed within one or more travel lanes, a lane closure is generally required. In the transition area, traffic is channeled from the normal highway lanes to a new path, which is required to move traffic around the work space. Most often, this is accomplished with tapers to close the lanes. The transition should be obvious to drivers. The correct path should be clearly marked with channelizing devices so the drivers will not make a mistake and follow the old path. If the existing pavement markings create confusion, temporary markings should be used. A taper is a series of channelizing devices placed at an angle to move traffic out of its normal path. Tapers are located either upstream or downstream of the workspace. The spacing for channelizing devices on tapers is based on several factors: the speed limit, the type of devices used such as cones, tubular markers, barricades, vertical panels or drums, and finally the location of the devices such as in the taper or the tangent. The taper length criteria for work zones can be found in Chapter 10 of the Plans Preparation Manual. The spacing of devices can be found in the Design Standards Index 600 series. There are 5 general types of tapers used in traffic control zones. It is important that you know what type of taper you will need and how to determine its length. Merging tapers close a lane of moving traffic on multi-lane highways where a merge is required. The length of the merging taper, which is used to close a lane, is determined by the speed of the traffic and the width of the lane to be closed. The formulas for determining the length of a merging taper are found in Index 613, Table 2. For a posted speed limit of 45 miles an hour and a lateral merge of 12 feet, you would need a taper of at least 540 feet, which is determined by the formula L equals WS. L is the length of the taper, W is the lane width, and S is the posted speed. For speeds 40 miles per hour or less, use the formula L equals WS squared divided by 60. Lane shift tapers move traffic to a different lane where a merge is not required. The taper length criteria for lane shift tapers can be found in Chapter 10 of the Plans Preparation Manual. A shoulder taper may be beneficial on a high-speed roadway where shoulders are part of the activity area and are closed, or when improved shoulders might be mistaken as a driving lane. When paved shoulders having a width of 8 feet or more are closed, use channelizing devices to close the shoulder in advance of the merging taper to direct vehicular traffic to remain within the travel way. Shoulder taper formulas can be found in the Design Standards Index 600 series. Two-way one-lane tapers control two-way traffic where drivers are required to alternately use a single lane. These tapers are used when flaggers are present. A short 50-foot taper is used to slow down traffic by giving the appearance of a restricted alignment. One or more flaggers or temporary traffic signals are used to assign the right-of-way in such conditions. The length of the taper is fixed at 50 feet as shown on Index 603. Channelizing devices are spaced a maximum of 20 feet to provide clear delineation of the taper. A closing taper is used at the downstream end of the work to allow drivers back into the lane that was closed. It's placed in the termination area. While closing tapers are optional, they may be useful in smoothing traffic flow. However, they may not be advisable when material trucks move into the workspace by backing up from the downstream end. If the closing taper is used, it should be 100 feet in length per lane. Let's briefly review tapers and taper lengths. Where traffic on a multi-lane highway must merge, the required length is a function of the speed limit and the lane width. When working on a shoulder, check Index 602, Table 2 to determine the required taper length. When traffic is on a two-way road and it is reduced to one lane, a 50-foot taper is needed. Downstream or termination area tapers are used to guide traffic back into the normal path. A 100-foot per lane taper may be used to let the driver know he may return to the closed portion of the roadway. If restricted sight distance is a problem, for example a sharp vertical or horizontal curve,